You want a laser?
All right. You guys ready? Yeah. Well, hello. We are. Oh, we're waiting. Okay, I'm getting ahead of myself. I'm sorry.
And I'm going to introduce you.
Oh, okay. Okay.
I started the recording just so I wouldn't forget. The other team's going to get docked some points there.
I know my team. I had caught up my second presentation, like 10 minutes. I had 5 teams in the first team, they never came back. Just, well, actually, one person in the team came back. He said, start it. He stayed. Everybody's presentation, right?
I did tell my teams earlier that they could go to other rooms.
Oh.
So but one whole team left, and I thought,
I keep trying to think about that.
Didn't go to anyone in our section. I showed them the ones that were here before us.
yeah, you've heard the rehearsals of the other teams, so you kind of know what they're going to say.
That's true. I didn't think about that. So long as they went to somebody at other sessions, and that's totally.
So we are recording these, and the recordings will be put on the senior design.
Okay, but they can't see us.
Yeah, they can't see you.
That's. They should. I wonder if they can use that camera.
No, you guys are. Yeah.
Is that one working?
Yeah, that's the one I use.
Okay.
So they won't be able to see you.
Okay. Well, because we're screen sharing on Zoom, can they also see us? You have to start the video. You might have to start the video.
Yeah, is it the wolf vision? It's the camera.
Well, they just like, oh, yeah.
You know what camera it is?
Yeah.
Got some technical difficulties.
Yeah, when I did video,
Okay, you gotta, I think you need to stop share so you can see with the camera.
that's not.
That's the video, so it might be a different one.
I think it's that one right there.
Oh, capture, yeah.
Yeah. that's
Yeah,
the
there
one.
we go.
Okay, great.
Now we can see ourselves. Perfect.
I do want to hear these chairs. One more minute.
Okay.
Product sound.
Oh, nice. Got one more.
Sure, I'm ready to check. How were you for time? You weren't running long, were you?
No, we were a little bit short.
Like,
But we added a few things.
Yeah.
Yeah.
Oh,
Which slides?
Yeah. I rush you.
Oh, fine. We can get this done in time. It's not that big of a deal. I don't know if you can see the lasers on the screen, like when it's recording. Yeah. I'm trying to find out. I found them.
Hanging out. Great. Okay, well, good morning, everyone, and thanks for coming. So we have this session, we have two teams who worked on highway design projects focusing on hydrology and hydraulics primarily. These are both projects essentially for the Michigan DOT. And so the first team here, CRM Engineering, worked at a project site over in Marquette where they're going to be constructing a new roundabout. So I'll turn it over to them.
Well, hi, we are CRM Engineering. My name is Braden Gunderson.
I'm Jacob Johns.
I'm Jason Senator.
So just a brief outline of what we'll be talking about today. I'll just go over an introduction, the scope of work, what was included in our project, some existing conditions of the site, what the site looks like, design tasks and challenges, the construction schedule and plan, the cost estimate, conclusion and recommendations, and then at the end we'll have time for questions.
The scope of our project is redesigning the culvert running under North Lakeshore Drive in Michigan, Michigan. MDOT is installing a new roundabout at this intersection, and it's going to alter the route of US 41 and change the culverts that direct Carp Creek. Our design will include a hydrologic analysis, hydraulic design, soil erosion and sedimentation control, construction estimating and scheduling, and the maintenance of traffic plan. This is a picture of the roundabout that MDOT is proposing. They're switching to a roundabout because they're all around safer with the tight curves, forces drivers to slow down. It reduces head-on collisions, left and right turn collisions, as well as increases the flow of traffic.
So here are the pictures of the existing site. Site one is the culvert we worked on mainly, and this is the one we designed. This is under North Lakeshore Drive in Ishpeming. Site 2 is a bridge under US 41. And Site 3 is a railroad culvert. Sites 2 and 3 we didn't change the design of those, but we did include it in the HECRES design to make sure that the waters wouldn't overtop or anything like that.
So these are the old 1992 plans, and these are the current version of what's there. So they extended North Lakeshore Drive, and they had the original culvert, which is a 10 by 10 foot span, 10-foot rise. And there used to be a snowmobile bridge just to the north, but that's gone now.
We figured that for this project, we need 2 permits. We need the Marquette County Soil Erosion Control Permit, as well as the Eagle JPA and then Lakes and Streams Permit. And this is because we are going to be doing construction within the creek. So we have to make sure to take the proper environmental precautions.
So a little bit on the site conditions. This is a soil boring from one of the existing plants that Braden was talking about. The borings were found to have mostly sand with firm gray clay and then fractured rock. And this enabled us, as well as the existing culvert, to just be placed on a solid subgrade without piling. So in order to design our new culvert, we were given discharge rates from Eagle. As you can see, at the railroad that Jacob was talking about, for the 100 flood event, the annual discharge was 550 cubic feet per second. And then under US 41 was 600 feet per second. And then Lakeshore Drive that we were designing for was 720 cubic feet per second. And the reason that these increase from the railroad, so the railroad is upstream, and then at Lakeshore Drive is the furthest downstream, and it increases as you go from upstream to downstream just because of there's catch basins on US 41, and then there's drainage from the parking lot that flow into Carp Creek. And then there's actually at the existing site at the culvert that we're redesigning, there's a drain that goes through the upstream wing wall that actually flows into Carter Beach. So just kind of to double check and make sure that we had the same data as Eagle, we used their discharge spreadsheet and found that we had a composite curve number of about 68, which was moderate runoff and infiltration, which the curve number just is a measure of basically rainfall runoff and how much that rainfall infiltrates the ground. The time of concentration we found was about 14 hours. This is based on the topography and geography of the land as well as the land use. And the time of concentration is basically how long it takes for water to get from the furthest part of a watershed, in our case, the Dead River watershed, to the water body, which in our case is Carter Creek. And as you can see down here, the 1% frequency is equivalent to the 100-year annual flood event. And we came up with about 667 cubic feet per second, which was similar to the 720 cubic feet per second that Eagle came up with. So a little bit on our actual culvert design. We used HY8 to actually design it. And the existing site, the culvert is a double barrel with a 10-foot rise and 10-foot span. And we're increasing this to a 10-foot rise by 12-foot span while maintaining the 2-barrel culvert. We did this in order to decrease our outlet velocities and then also extend the lifespan of the culvert, just because of the lower velocities, it won't have as much of an effect on the culvert. As you can see in this table on the right, the outlet velocity for the 100-year annual flood event was right around 10 feet per second. MDOT calls for an outlet velocity less than 6 feet per second. This is just so that it doesn't wash out downstream, and anything greater than 6 feet per second, like we have here, requires special treatment. So we are implementing a Riprap Basin. This will basically transfer the flow from supercritical, which is your whitewater flow, to subcritical. We were able to effectively reduce the average tailwater velocity to 2.8 feet per second. And then we'll talk a little bit more on the next slide. So because we weren't able to actually get to the site and see if there was a scour hole right after the culvert, we decided to plan that there was a scour hole and implement a riprap basin. Based on HY8's calculations, the riprap basin is going to be 96 feet long downstream, 50 feet wide, and then 2¼ foot thick. It's going to consist of class 1 riprap, which is, you can see on the right. This is going to be an estimated 600 tons of class 1 riprap. And then on the next slide, just as kind of a contingency, we're not exactly sure if there is a scour hole, because the 96 feet downstream is very excessive for riprap. It's a lot and it doesn't necessarily need that. But that's just what HY8 came up with. So if there isn't a scour hole, like as you can see over here, this is taken directly from the HY8 manual. This is the scour hole, this initial dissipator pool. If that is not there, this whole dissipator pool section will essentially be taken out, and then the riprap apron will be shifted up. And this apron will only be 24 feet downstream, but still remain 50 feet wide and 2¼ foot thick. And this would only employ 150 tons of class 1 riprap versus the 600 tons with the basin. And this would save an estimated $8,800 in material.
So along with HY8, we also used HECROS, and we modeled the existing and the new design. For the existing culvert, there's a hydraulic jump at around the 1% storm event at 720 CFS. I mean, that's 720, yeah, 2 feet per second. The exit velocity is averaging 8 feet per second, which is again above the 6 feet per second standard set by MDOT. For the new culvert design, all the exit velocities are lower than 6 feet per second. I think it's around 3 feet per second at the end, which is what I got. And there's also no overtopping for any event up to 0.2% that we saw. And then we did attempt to do the riprap design within HECROS, but the software itself is in beta and it only represents 1 dimension. So we ended up not using that and just sticking with the HY8 design. And along with the HY8, we did traffic management plan. So the current plan right now is to take all the traffic that's going to the intersection to Lakeshore Drive. We're going to push it up to Country Lane and across Parkway, River Parkway. And the Jubilee Foods down here will still have access to North Lakeshore Drive, but this will be closed to through traffic as the construction site is going to be closed off.
So the remediation plan for our project, we are saying that we're gonna need approximately 70 feet of silt fence. We're gonna place this at the north end of the culvert as well as some near the front of the temporary culvert. And this is just to reduce pollutants caused by the construction. We're also using a filter bag and pump. And this is again to reduce pollutants from leaking into the stream as well as reducing water leaving without being processed to get all of the contaminants out. Our construction schedule follows our 6-phase construction plan, which we'll outline in the next slide. We estimate that it will take a total of 11 weeks to complete. There are 42 tasks, and every task on the schedule is part of the critical path, meaning that any delay in any task will result in ultimate delay of the entire project. And for our schedule, we assumed maximum production of all equipment and no delays. We realized this was unrealistic, so we added substantial flow time, upwards of around 3 to 4 weeks, I believe. And then on the left side there, or your right side, that's just breaking down the 6 phases and which ones take the longest amount of time for the total project. So our 6-phase construction plan, phase 1 will be a temporary culvert and sheet pile install. Phase 2 and 4 are exactly the same. It's going to be demoing half of the roadway and existing culvert. Phase 3 and 5 are also the same. They'll be installing half of the new culvert in the demolished area. And then phase 6 will be removal of the temporary culvert.
So as Mehdi was talking about, phase 1 is going to be the temporary culvert install. So south of the culvert, we're going to be taking out, I think 140 feet of area and putting in 140 feet of 96-inch CMP, and then taking sheet pile and cutting off the canal so that we can direct the water into the temporary culvert. And then phase 6, after the other phases are done, that's going to be ripping out the temporary culvert and then brief backfilling. And then for phases 2 and 4, so when we start, it's going to be the southbound lane first. We're going to remove the southbound lane, all the pavement and the subgrade, and then remove all the culvert sections underneath, put down our base, and then put in the culvert sections, then bury it. And then we move on to the northbound lane, take everything out, put everything back, and then pave back over it. So he'd still have access to both sides during construction.
So our estimate, this is our estimate for our materials. The materials include stuff like the subgrade, backfill, riprap, the culvert cost. Highlighted here and up there are our main biggest cost items, which include the precast culvert, which we got from a quote from UP Concrete Piping Company. Our temporary culvert, our wing walls, and then our sheet. These prices were mainly, all these prices were found from quotes from contractors, and then stuff like the class 2 sand, that stuff was found from RSPs. So here are our equipment and labor costs. Labor at the top there, that includes all the operators, truck drivers, laborers that we'll need. And then our equipment, this is all the rented equipment out. And so our total cost estimate comes out to about $1,455,000. This is just for the culvert reconstruction, not the roundabout design itself. And then in here we have the labor costs, material costs, equipment costs, and then subcontractor costs, which is basically every aspect of the project that we're subcontracting out. So the signage costs, that's just one lump sum that we calculated. Guardrail removal, installation, and then road resurfacing. And this accounts for 15% overhead. So just to wrap this up, the main points of this is we're increasing the size of the culvert from a 10-foot span, 10-foot rise to a 10-foot rise, 12-foot span to a decreased outlet water velocity. We're adding a Riprap Basin to prevent erosion and serve as an energy dissipator. A detour will be implemented to still provide traffic to all the businesses and access to private properties. And then construction's broken down into 6 phases. It'll take around 11 weeks to complete. And then the cost of the project, as I just stated, is about $1,445,000.
So CRM Engineering recommends that the culvert under North Lakeshore Drive not be built for 2 reasons. The current culvert is only 30 years old, and MDOT standards specify that culverts are designed for a 50-year lifespan. So it's only 5 years over its half design lifespan. And it seems like it's in good condition. This was the only picture you'll be able to get with winter and the snow. And then North Lakeshore Drive culvert does not need to be moved to accommodate the MDOT roundabout. They stated in their proposal plans that it will not be altering the route at that culvert. We recommend instead doing a study, as we were mentioning earlier, to see if there's a scour hole, and if that scour hole does exist, implementing either the Riprap Basin or apron, depending on the problem itself. Any questions?
Yes, I have a question.
Yes.
Can you go to the slide where you're talking about the hydraulic jump?
Yes.
It's been a while. Yeah, this one. So can you explain to me what a hydraulic jump is and two, why it's important to identify the location of the hydraulic jump?
Okay, hydraulic jump is when it goes over a velocity difference, so it changes as you go through, like going into it, and it can cause higher velocities at the end and can cause more scour.
How did you identify? How did you figure out that's what it was?
That's where it was. Well, actually, I had Dr. Watkins help me with it, because we were looking at this together, and he saw the jump and he told me about it, and I'm still understanding what exactly it is, but he's definitely the one that helped me with it.
Question.
Um,
Right, so just.
No, you can follow.
So, yeah, I mean, the water is, you can see there, the slope is steeper through the culvert in the model. So it's accelerating there. It's also contracting.
Mhm.
So it's related to the specific energy, but when the flow contracts, you get higher specific energy, higher flow per unit width. So it transitions there from subcritical to supercritical, but right there is a scour potential.
Got it. Okay. I have one more question. You had a slide later on with the construction of the culvert, precast box components. Yeah, I'm not familiar with this type of segmental construction. So culvert, right? Water, large volumes of water going through.
Yes.
So is there any special joints that you have to have between the individual segments? Is there like a gasket or something?
For like the segments like horizontally or the
You
barrels?
have individual segments, right?
They get sealed together.
Oh, they get sealed together. So
Yeah.
how does, I'm just curious.
Usually it's like a plastic or like a caulk that they pump in, they pressure them together and they stay together. It's the same thing they do in between both sides of the culvert, both box culverts.
So you're kind of basically, layman's term, they put caulking in there.
Yeah, they basically glue it together.
Okay. Okay.
Then after they're stuck together, they'll go inside and then take grout and then kind of fill in any cracks that water can't force its way in.
Okay.
Mess up that
Okay.
river top.
So they seal up the cracks you said?
Mhm.
They
Yeah.
inject them? Okay, cool. 'Cause I was just gonna ask you, they put a liner inside to, because, concrete shrinks and cracks. They put a liner inside? Or they just seal the
No,
cracks?
yeah, they just seal the cracks with grout.
And I think they might treat it with something, but I have no idea what they're gonna do with that culvert. But I haven't seen them put linings on any box culverts.
I think some precast companies will actually treat the precast before they send it out into the field. But in this case, we weren't told that it was treated.
Right.
But I know that some companies do that.
Yeah, I was just curious. But that flex seal spray stuff. Okay, that's all I had. Thank you for the presentation.
Students, any questions?
Guess the only question I have, I don't know if you can answer this or not, but looking at that culvert, it's a pretty big culvert. And environmental aspect, not civil, like, when does it become feasible to just build a bridge instead of putting in a big culvert like that?
You know, it's kind of confusing because they do also have a bridge at US 41, which has less flow rate, but it's a bigger opening. So I don't know how MDOT chooses when to make a bridge rather than a culvert. Sometimes it's kind of just like pick one.
You're looking at the same thing.
Yeah.
Yeah, I don't know.
I mean, what I saw,
Hydraulic engineer and a bridge engineer.
I mean, when I was working for the road commission, we were redoing culverts. They kind of just like pick and chose whatever they wanted. Because there was a bridge that fell down and they're going to replace the bridge with a culvert. So kind of just pick it.
So the question was, why not, I'm sorry. I didn't catch your question. So your question was, why have the culvert there versus just having like an open flow channel with a bridge?
Yeah.
Kind of like how they have it at over US 41.
Okay.
I think also bridges are a little bit more expensive because you have to have beaming and steel, whereas culverts, they still have steel in like the rebar, but it's not as much as beams. So it's just a cheaper alternative probably.
That's what my guess would be. It's all coming down to the cost. My guess.
Yeah, and there's probably implicitly like a greater safety factor for US 41 for that hydraulic flow.
Mhm.
Why would you have a bigger, why would you have a bigger
Yeah.
opening there for less flow? Hydrologic analysis, but it's more important.
Also, I think semis use 41 and they don't use North Lake Shore Drive, so they might be accounting for heavier loads.
I think this culvert was, so it was built in 1992. There was nothing there previously. It was just, there was no intersection that went north. It was only South Lake Shore Drive. And I think the culvert was implemented there because a hospital was built just about a half mile north of this culvert. So I think that that's why they're looking into redoing it or making sure that they had access. Because the hospital is, it's really easy access off 41 to go north. Get there in an emergency.
I have one more question. That I just thought of it because, questions lead to more questions. So am I to understand that the highway traffic goes directly across this culvert? That is traffic this gets buried, right? And then the traffic,
Yes.
the highway literally goes across it, right? Is that right?
Yeah.
Yeah.
Okay, so the question I've got is, I'm assuming you guys didn't, this is a pre-engineered culvert, so you didn't have to do your own calculations for the traffic load that's required?
No, not for the actual box culvert.
Okay. So I'm wondering why, I'm looking from a structural integrity point of view. Transferring loads, heavy loads, having rounded culverts versus a box. 'Cause
Yeah.
if it's flat on top, literally, I mean, with the round culvert, you get arch action in your culverts. So
Yeah.
structurally, the elements are much more efficient versus a box culvert, it's flat on top. Literally, you have to design that as a basically a one-way slab. I guess I'm curious why the box culvert versus, I don't know, do they need to make big round culverts?
They do, but those are a little bit more like specific or
Okay.
They're a
like,
lot more expensive.
yeah, you have to get those made specifically. These can be made like massively because they're just squares, easy to print.
I mean, I see, round culverts have its own issues because, then you got to deal with the support, right? Versus it's flat on the bottom, So, but
Yeah, I think these save a lot of money just because the constructability is a lot easier. Because like, as you can see there, the subgrade, you just lay it flat with a little bit of grade, depending on the slope of the culvert, and then just compact it. And then it's basically like stacking Legos. You just set them down and then make sure everything's compacted.
Yeah.
And you just set the road across. So it saves a lot of money, I think. For
And it'd be easier to get it to seal straight because if you have a rounded culvert, it can move a lot easier.
yeah, right. Okay.
Great, good question. Thank you.
Dr. Dunn, did you want to leave this up here for
Yeah,
them?
leave it for the,
Okay.
next team.
Okay.